All right, boys, let's take a look at a graphing today. So we've got our worksheet here about different types of graphs. You can see we've got pie graphs, bar graphs, histograms, line graphs, and scatter plots. We've already talked about the general premises, and of course you can see some definitions here. So I want you to make sure you go through our table here and make a decision about which of these types of graphs would be most useful. Again, using the premise, again, our basic descriptions that we have here. So use those definitions and descriptions to help you put those X, right, where or with the graph that would best represent that. Okay. Today I want to work on some specific skills. One of the skill sets that guys often struggle with is identifying a dependent and an independent variable, which is an important one because the big difference can be, how our graph looks. So, for example, I can have a situation where someone creates a graph that looks, like this, or a graph that looks like this, depending on what they put on the variables. One of those is right and one of those is wrong. So I want to talk about what I like to use in order to help me figure that out. So I actually have a little acronym that I picked up a few years ago from a student who got it from a teacher. So I kind of stole it, and I've been using it since. And my acronym is dry mix. So it's just a little quick thing, just like King Henry died by drinking chocolate milk for converting metrics. Dry mix is a way for me to help remember just the correlation between dependent, independent, and the X and the Y axis. So let's go ahead and go through what those mean. So this is my dependent. Okay, again, this is just to help me remember what these terms mean. The dependent variable is the one that is responding. Okay, not the one I changed directly, but the one that's going to respond as a result. And I'm always going to put that on the X axis. So I can either use that to create a graph or read a graph. Right? The y-axis is always going to have my dependent, that's the variable that responds, versus the one I can directly manipulate. Okay? For instance, I can control how long I study, but I can't directly control what grade I get. So I can change how long I study. Right? This is going to be known as your independent variable. And it's always going to go on the x-axis, as you may have already deduced. Okay? So the main thing I ask myself is when I look at a description, so for instance, they give me a simple description of graph 1, and they ask me the question, essentially, what goes in the X and the Y? So when we say label the axes, we mean determine the dependent and independent, and then label it accordingly. So the way that looks is this. A ball is dropped from several distances above the floor. They give me a unit. And the height it bounces is then measured in centimeters. So we ask ourselves, can I directly control the distance I drop the ball or how far it bounces? And we should conclude that it's how far I drop it from the floor, right? And I can write distance from the floor or distance above the floor, but the students often come up with different ways of saying this, and the common one that we settle on is usually drop height. So just come up with a term, right? Drop height is good. There's a descriptor. Height is an actual measurable property, so that's a good one. And then it tells me meters. So I like to put my unit in a parentheses and I can abbreviate the unit. I can write the whole unit out, but abbreviate it's a little bit easier, right? If you want to save yourself just a moniker of time, you can do that. Now, versus height it bounces. So kind of sticking with the same premise, many of my students come up with the idea of bounce height. So we write bounce height and we include the units. Again, this exercise is simply to get the idea of finding the dependent and independent, because it's very important that we do that, because if we do that wrong, again, my graph will look one way or the other, and it is important that I identify them correctly, right? And then for graph 2, for example, says a candle was burned under glass jars of different volumes in milliliters to see if the volume of the jar affects the length of time in the candle burn. So again, we ask ourselves, what can we directly control? Right? We can control the different jars. So in this experiment, I can use different volumes of jars. So let's kind of follow the same thing. Descriptor, measurable property, right? So I can control the jar volume. In other words, I can pick up a big jar and put it on there, or I can pick up a small jar and put it on there, right? But I'm going to actually have that quantifiable, so I'm going to measure it in milliliters. Okay. Therefore, what responds as a result, right? The length of time the candle burns. So again, if I kind of follow this general premise, if you're trying to create a name, sometimes a descriptor and then a measurable property, right? I might say burn time, right? That's always a good way to do that. And then, of course, I need a unit for time, and seconds is always a good unit for time. Good go-to when it comes to time. Again, property, and then my unit that I've used it. If I need a descriptor for my property, great. Okay, excellent. All right, so I'm going to leave those two for my guys to go ahead and finish up. Again, same idea. You can pause it and ask yourself the same questions if you're just watching the video. Either way, we're going to go ahead and move on to another premise. So the other thing my students often struggle with is scaling and axes. Scaling and axes. Now, I'm going to say a couple things here that probably some teachers will disagree with, but I do it for my boys for a couple of reasons. So I'm going to start this off. Basically, what you're going to do anytime, again, there's a nice description of here as you read through it. The idea is that we're going to find the range, the largest value, the smallest value, right? Range, which we've probably learned in math class before. We're going to divide that range by the number of intervals. As in, when you're looking at a graph, for example, the one on the back of this sheet, if I'm going to find out intervals, I need to count how many lines I have, okay? And when I count how many lines, that's the number of intervals. So the easy way to do this is to find those. Now, in this particular case, I'm actually going to start mine smallest is 0. I want my boys to start off with 0. I know they can do it another way. You can certainly start at another value. I'm going to do it for my boys for a couple of reasons, and then I teach them later to do some other premises, right? So if I look at this, let's see, 100 is the biggest number, 12 is the biggest number, right? Right here I've got 1.74 is the biggest number, right? So each one of these is pretty simple to find the range when I make it 0, right? So this is much easier than what the worksheet was intended for originally. Okay, and I walk my boys through a different version later on. Okay, so the range was 100, the range was 12, the range was 1.74, and it tells me right here that my interval is 10 intervals. Right? So I take the intervals. In other words, I count the lines on my graph. Right? So 10, it says it's 10 for all of these, right, according to that. Right? So I have 100 over 10, so each line should be labeled 10, which is ideal, right? The boys love when it comes out to be a nice even number. I have 12 over 10, I get 1.2. Now, this is where guys start going, wait a minute, I don't like decimals, things like that. You can round this number a little bit, right, to help you out. Don't round down. If you round down, you're going to run out of space for your data on your graph. Never round down. You can round up a little bit. Don't round up a lot. Okay, 1.5 might be reasonable. That way, every other line could be a whole number. That might be a good choice. And again, we'll walk you through something like that in just a minute. Right? Versus the same thing would happen here, right? As you see, I get this basic value dividing by 10, like 0.174. Again, I'm really not going to want to label 10 to 20 lines, 0.174. Okay? So as a result, right? I've got this idea where I might want to round that. So I might round that one to like 0.2 or something, just to make my life just a little bit easier, right? And to make my graph look nicer, right? It's a small rounding. I'm not going to round a lot, right? But I'm still going to round, okay? From there, some basic number line stuff, right? So the idea is, again, okay, so I can create a scale. One of the really important things is that my scale has even increments, right? So this is basic number pattern. I mean, this is elementary things that we've done in elementary school. So I'm going to start off with I'm going to go ahead and jump to the bigger ones because I know as boys we can find all these other patterns in here. But the main thing is if your smallest number is 0 and your biggest number is 24 and you have 6 lines, well, you just do your division, right? 24 divided by 6, right, gives me 4. So I end up 4, 8, 12, 16, 20. That's what I should do. No matter what you do even increments, right? Here's a good example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I have 2.2 divided by 11, right, I get a value of about 0.2 for each one of them, okay? So 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, and all I did was what's the big number I want on the end, divide it by the number of intervals, and that gives me what I should label each line. Okay, it's a general simple idea of what we're going to do. Okay, so let's actually put this in practice. So this might be a little bit more subtle, right? So here I'm going from 0 to 12.9. Here I'm going to go from 0 to 90.6. Okay, oop, that doesn't look like a 6 at all. There we go. All right, and let's count our lines. So first I need to determine, right, what I'm going to do for this. This is time and distance. They've already labeled my axes for me. That's nice, right? So I got time and distance. Now the time one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to take that 12.9, divide it by 9. right? So if I take 12.9 divided by 9, so if you grab your calculator, if you don't want to do the mental math on this, that's okay. Okay, divided by 9, okay, I'm going to get about 1.433. As you might suspect, I probably want to round that a little bit, so I'm going to go ahead and go with 1.5. Okay, so I could go 1.5, 3.0. Now here's another thing I'll tell you while I'm doing this. I don't have to label every line. Okay, now it still has the value. This line is worth 1.5. So if I write 3 here, this line is still worth 1.5. I may not write 4.5 here, but I can write 6 here, and that line still has a value of 4.5. And I continue that process up. I don't have to label every line. I might not want to, just because I literally don't have space. If I have a graph with really tight grid lines, that might be a problem for me, right? Now for distance, I'll have 90.6. Again, count your lines. Don't assume. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in this case, I had 10 versus the other one. So we have a bit of an issue here, okay? Because you got to count. That had 9, that had 10. If I had assumed, I would come up with a different answer, right? So when I divide this out, I get about 9.06. And again, as you might suspect, I can't round down to 9. That'd be nice, but if I do that, I'm going to run out of space. So I'm going to round up, and I'm going to round up less than 10%. So I'm going to go and take it to 10. So that means 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Cool, my data will definitely fit on there. And you can always check it that way before you start writing stuff down. Again, I don't have to write it on every line, right? But if I'm going to do that, if you write on this one, then you're going to write on every line. If you're going to skip the first one, again, this has a value of 0 because that's where we started, right? So if I 10, 20, I'm not labeling the 10, it still has the value of 10, right? Here I'm going to have my 40, my 60, my 80, and my 100. So figure out your range, right? Figure out how many lines you have, count them, make sure you're correct, okay? Because like this graph, it had 9 and 10, respectively. If I'd assumed, I probably would have made a mistake, right? This is just plotting points. Now, this is what guys sometimes come across, and the problem for them is the fact that they're kind of used to elementary graphs, perhaps. Maybe they don't recall that, and they like that. It was really nice when the data points were exactly in the grid lines. They were always perfect, and that was great. In the younger grades, that's how they do it. It's not how we do it anymore. That's not how data is in the real world, right? So each one of these, now this is kind of convenient because they do stay on the lines a little bit. Okay, but it doesn't. These numbers should match. So see how this is 5, 10, 15, 20, 25, right? It doesn't say 15, 17, 19, 21, 23, 25, right? Because those are not the increments that I'm looking for in this particular case, right? So time, that's down here. Score, that's over here, right? So we're going to have a time of 10, a score of 15. So we're just going to put our points on there well enough that we can see them. Okay, and we're going to keep going from there. So if we go to 20, right, we're going to go to 17, which means I'm a little bit above 15, right? Again, I'm estimating between the two values since I don't have grid marks, and that's fine. Right? I've got 30 and 19, which means I'm just below 20, for example, right? 40's got 21, which just is above 20, right? For 50, I've got 23, so I'm going to go above 20, higher than 21, not quite halfway, right? Because then that would be 25. Right, and then I've got 60 is going to be at 25, right? So now I'm going to be at 25. I want to be right there in the middle if I can get as much in the middle as I can, right? For 70, I'm going to 27, so I got to go a little bit higher. Again, not all the way, but just a little bit higher, right? For 80, I go to 29, so I should be just below the 30 mark, okay? For 90, I'm going to go to 31, which means I should be just above the 30 mark, okay? Oh, did you catch my mistake? I did. I caught my mistake. All right, so my 50 should be 23. We're good there. My 60 should be 25. Look at that. Look, I made a mistake. I wasn't paying attention to what I was doing. Look at that. Oh, no. And that's why I use pencil when I make graphs. All right, 70, I should be at 27. So sorry, I was looking at my mark wrong. So 27, I started to think each line was worth 10, not 5. Oh, no. Misconceptions are true. All right, and then 80. We're going to go to 29. All right. So hopefully you're one of those, oh, no, he's making mistakes and calling me out. If you were, good for you. Yes, I make mistakes too. It's okay. That's why I like pencils and a good eraser. Okay, so we have a lovely graph, right? Pretty linear, right, to the most part. Okay, and then there's more practice, the idea of getting to good spaces there. All right. So that's basically how we graph. Again, the primary premise is identify what kind of graph you're going to make. Know the difference. No one should have to tell you what kind of graph to make. You should know what kind of graph to make based on your knowledge of what graphs should be used for. I'm not going to use bar graphs for what we just did because the data is quantifiable. Right? I'm not going to use pie graphs because I'm not talking about part of a whole. I'm not talking about percentages. Line graphs are really great for change over time. Right? Time will be on the x-axis probably 9 times out of 10. But scatter plots are where the real data lies. We probably make more scatter plots than anything else in my class because that's more likely to be an analysis. So again, work on identifying your dependent, independent variables, right? Be able to tell which one it is and place it on the correct axis, because if you put it on the wrong axis, it's going to mess you up quite a bit, right? Your graph is pretty much going to be inverse of what it's supposed to be, right? When you figure out a scale, take your data range, divide it by the number of lines on that scale, and there you go. Never round down, round up a little bit if you need to, right? But not too much. Again, when you do those increments, again, figure out your range, divide by the number of lines, round up a little bit if you need to. So I rounded up a little bit. I didn't go too far. I didn't round this to 2, for example. Okay, I didn't go too far. This is going to give me a good graph where I've got data in probably 90% of the graph, right? I don't want all my data to be down here in the corner by itself. Okay. When you plot your data, make sure you don't make little mistakes like I did, right? Make sure you pay attention to these lovely lines you've already created, because before we ever put data, the rest of it will already be done. Okay. And from then on, the bottom line is you'll be given data, you'll be given a grid, and your job is to label. So make sure that you put a title, label the x and the y axis, the x and the y. Put your units on there, then determine your scale, right? Figure out your range of data, 0 to 100, 0 to 10 in this case. Divide by the number of intervals. You'll have to count to figure out what those are, okay? Go ahead and place those on those lines. You can skip every other line, right? For labeling, this line still has the value, okay? And then from there, you'll have a lovely graph after you plot the data, okay? But make sure, before you worry about the data, you have labels and even increments on your x and y axis. All right, good luck graphing out there, guys.